Okay, here's a new course. It's called Random Processes and Kalman Filtering. Random Processes and Kalman Filtering. It's a course I've taught about 8 times at Washington University in St. Louis. After the first, 3 times I taught it, I ended up just writing my own textbook, in effect. I say textbook, I didn't get it published or even bothered to try to get it published. That textbook is on my website. Its URL should be down in the description here. This was a senior level course. Every place I've seen Kalman filtering taught, it was a graduate level course. So the point was to make it accessible to undergraduates. I still needed to know some stuff like basic probability and some level of control systems on signals and systems. Anyway, that's what the course is. Let me bring up, I just want to introduce it, kind of put it in context because it's a little bit different of a course from my other courses. All right, here we go. Course. There we go. There's my little laser. Okay, finally. So there's the name of the course, Random Processes and Kalman Filtering. I asked AI, what is a Kalman filter? This is what it gave me, and I think it's a pretty good answer. First of all, it's a mathematical algorithm used to estimate the state of a system over time, or anything that changes dynamically. That's when you have measurements that could be noisy and incomplete. A typical thing is like, what's the position and velocity of a vehicle, for example? I won't go into the rest of it. Again, the Kalman filter itself is kind of the destination of the course. There's the journey to get there. And I put it in this context. It's a systems context. Signals and systems. What are signals? They're just a sequence of numbers. It could be a continuous sequence, like a function. And a system is just something that converts inputs to output signals. That's the paradigm of systems, signals and systems. And things were kind of ambitious just if there was nothing random about it. If you give it a certain input signal, what's going to be the output? If you observe an output, what input caused it? If you're given both input and output, can you model the system in the in-between part? What inputs should you give it to get the outputs you want? How could you modify the system or put it in a feedback loop? These were pretty tough questions to ask and answer, even when there was nothing random. That would be like your basic control systems code. Now, what if we start having noise or errors involved? You could have noise or errors on the input to the system. You have noise and errors on the output of the system. What you actually measure is probably going to be a little bit noisy because you don't have perfect sensors. We're going to model these noise sources, random processes. So we're going to have to talk about random processes. And to talk about that, we need to talk about probability. And anyway, here's kind of the basics of a Kalman filter. It's over here. But you have some input you want. It's corrupted. It goes into your system. Your system might have a whole state vector X. And you might not, what comes out of it might not be the entire state. And what does come out of it could be corrected by noise. And that's what goes into your Kalman filter. Then you have a system model. And anyway, what comes out of the Kalman filter is an estimate of the system's state. And this will all make sense to you if you get through the entire course. And you might want to skip over certain parts of it. But here's basic, I'm going to call it modules of the course. You got to start out with probability review. We'll get into random processes. We'll sort of review linear systems, even when everything is deterministic, meaning not random. Then we'll get into linear systems driven by random processes. We call it state space analysis, optimal estimation, and then finally the Kalman filter. Then after that, the extended Kalman filter for nonlinear systems. So it's going to have this many, what is it, 8 modules? And that's what the course is. Maybe you're not interested in that, but that's what it is. The first thing I'll be putting up is the probability review. Even if you've had it before, you might want to at least skim through it, because there might be things you thought you knew and you didn't. Anyway, that's the introduction to the course. Hope some of you enjoy it anyway. Bye-bye.